crack the code on one of the most perfect shapes in all of geometry, the circle. We're going to break down the hidden language that governs everything you see, from a simple pizza slice to a planet's orbit. We'll turn those complex rules into simple, visual ideas you can actually use.
So here's a question for you. What could a slice of pizza possibly have in common with the massive orbit of a planet? I mean, really? Well, the answer is pretty cool. It's all about the surprisingly elegant and totally predictable language of the circle.
To really get a handle on a circle's rules, you have to start right where all the action is, its heart, the center point. You'll see that every single principle we talk about today starts with the angles that come from this one single spot.
And here it is. This is a central angle, and it's our foundation for everything. Its vertex, the pointy part of the angle, is sitting right at the exact center of the circle. Everything else we're about to cover, it all builds from right here.
So, to really see why this central angle is so important, let's put it side by side with another type. See, on the left, our angle's vertex is at the center. But on the right, look at that. The vertex is on the edge of the circle. That one tiny change in location, it creates a completely different set of rules. For what we're doing today, we're focused on the power that comes from the center.
Okay, so now that we've got a handle on angles that start from the center, let's see what we can actually do with them. It turns out these angles are the key to measuring pieces of the circle itself. And this is where geometry gets really practical.
The easiest way to think about this is with pizza. Seriously. A central angle doesn't just hang out in space. It literally carves out a slice of the circle, which we call a sector. So, the wider the angle, the bigger your slice of pizza. And that crust on your slice, that's what we call the arc. Bigger angle, more crust. Simple, right?
So how do we figure out the exact length of that crust, the arc? We use this formula right here. Now, I know it might look a little intimidating, but the idea is actually super simple. All we're doing is taking our angle, that's the Greek letter theta, and dividing it by 360. Why? To find out what fraction of the whole pizza, or circle, we're talking about. Then, we just multiply that fraction by the total circumference. That's it.
Let's see it in action. Make it real. In this example, our angle is 315 degrees, and the radius is 11 feet. We just pop those numbers right into the formula. So, 315 divided by 360 times 2 times pi times 11. Boom. That gives you the exact length of that orange arc you see highlighted. Simple as that.
Okay, we've got the crust covered. Now what about the whole slice of pizza, the cheesy part and all? That's the sector area. And you'll notice the formula is really similar. We use the exact same fraction, our angle over 360, but this time we multiply it by the circle's total area, which is just pi times the radius squared.
Let's try this one out too. We've got a 60-degree angle in a circle with a 10-inch radius. Again, we just plug in the numbers. We take 60 over 360, multiplied it by pi times 10 squared, and that calculation gives us the exact area of that shaded slice. See? Not so bad once you get the hang of it.
All right, we spent a lot of time inside the circle. Now let's shift gears and see what happens when straight lines from the outside world come and interact with it, touching it in a really specific and honestly a really important way.
This brings us to something called a tangent. Now, a tangent isn't just any old line. It's special. It's a line that perfectly skims the edge of a circle, making contact at one and only one point. It just kisses the edge and keeps going. It never, ever crosses to the inside.
Now, tangents follow two really cool rules. Here's the first one, and it's a biggie. A tangent line and the radius that meets it right at that point of contact will always form a perfect 90-degree angle. Every single time. This is awesome because it creates a right triangle, which is a massive clue for solving all sorts of problems, usually with our old friend, the Pythagorean theorem.
And the second rule is just as neat. If you draw two tangent lines from the exact same point outside the circle, the lengths of those tangent segments, so from that outside point to where they touch the circle, well, they're always going to be equal. Always! Some people call this the ice cream cone rule, and if you look at it, it kind of looks like one, right? It's a perfect way to remember it.
So, we've decoded some of the circle's core language. We've talked angles, arcs, tangents. But you might be asking, why does any of this matter? Well, because once you see these rules, you realize this code isn't hidden at all. It's actually in plain sight, absolutely everywhere around us.
Just think about it for a second. The spin of a bicycle wheel. The way gears in a machine mesh together perfectly. The path a satellite takes around the Earth. The incredible strength of an architectural arch. even the face of a clock. All of these are completely governed by the exact same rules of angles, arcs, and tangents that we just covered. So the next time you're out there looking at the world, remember this geometric language. These aren't just abstract rules you find in a dusty old math book. They are the literal blueprint for how so much of our world is designed and how it functions. Now that you know the code, what are you going to see differently?